Welcome for the session of module 3, that is programmable logic controllers. Subject is mechatronics for 7 semester students, mechanical engineering. Okay, this particular chapter, which consisting of several concepts, in that particularly the outline of the chapter is discussed, um, should be contain that introduction to PLCs, that is programmable logic controllers, and second one is basic structure, how the basic structure is work, and is consisting of what are the elements which consisting of, and principle of operation, how it operates, means the programmable logic controllers, how it operates, based on which principle that logic controllers are operated as per our requirement, we're going to discuss in this particular chapter. And programming, as well as the concept of the ladder diagram and concept of latching and selection criteria, these are all which is consisting of this chapter, consisting in this chapter to discuss, to gain the knowledge of this programmable logic controllers. Okay, we just move on to this introductory part of a programmable logic controller. Whereas this, the any computer having an input and output interface can be used to control the external devices. However, the most of the computers are not industrially hardened. Means in this particular introduction, which is saying that how the what is the basic concept of the programmable logic controllers. In any computer, we know that any devices or any circumstances which is having an input and output, which should be interfaced with some controlling devices. We know that input, afterwards that is controller or microcontroller likewise, and then we having outputs. Means the input signal has been converted into some process in processor, so that will give the desired output. Likewise, this is very quite common. However, the most of the computer are not industrially hardened. Means this kind of computers are not particularly programmed for the particular organ, particular devices. Means whenever the input and output of a devices are general purpose, the microcomputers are not engineered or to handle the line voltage and the current above the transistor or a transistor logic levels. Means whenever we having some input and output for particular device, that is on general purpose machine, general purpose microcomputers are not engineered to handle the line voltage and the current above the transistor and transistor logic levels. Also, they are not designed to withstand the temperature, humidity, vibration on the shop floors. These three drawbacks, means these are all the drawbacks of a general purpose computer, have been rectified by the developing a programmable logic controller with built-in isolation into their input output. Means general purpose computer have different purpose to operate, whereas the industrial computer should have possess some different kinds of a process, and that should be subjected to various condition like temperature, humidity and vibration, and also on some shop floor drawbacks, just like a various noise and various obstacles to operate. As of that uh, general purpose computer that doesn't have any such obstacles to operate the system, whereas in this case, these few drawbacks are should be there to uh, attain a industrial perfection. Likewise, this computer, this particular programmable computers, just programmable logic controller, has to be secure within that within that same computer, so that it possesses some extra performance with industrial application purposes, so that these PLCs are within the that element only, that has been isolated in their own system to get desired output from required input. And whenever the programmable logic controller is defined as a digital electronic device that uses a programmable memory to store the instruction and to implement the functions such as logic, sequencing, timing, and counting, and some arithmetic operations, that is arithmetic word, to control the machine process. We know that the machine level languages are a very different language. We know that the any system which is logically programmable machines are understand only binary inputs, means that is 1 0, means half and condition. Likewise, the programmable logic controllers is defined by digital electronic devices, so it use the programmable memory to store the instruction. Means this programmable memory has been the set of instruction to give the operation purpose. So it consisting that uh, programmable memories to have their own sequence, means from for example, we need to on the first system, means we need to supply the uh, power to the system. That is, whenever we starting the start using the on button, then the power supply is occurred. Means the logic between that operation is to supply the power only. So when we using the start button, then the power supply is occurred. Before that, logic is 0. Whenever the signal is 1, the power is supplied. So this is the logic behind that programmable logic controllers. So that has been instructed with very long pages to have their own operations. Means that set of equations or set of lines or set of instruction is known as program that should be stored within the system to implement their own function of a logic, that is sequence, timing, counting, arithmetic operations. Likewise, there should be a the various computer system which is operate this logic and arithmetic, likewise decision making. These are all under this programmable logic controllers only. Whereas another concept, that is PLCs are generally used to incorporating automation in open loop system, whereas where the process are to be performed in a sequential manner. We know that the open loop system which doesn't have any feedback system, so generally these PLCs are used to incorporating automations. Means automation, it's a is a purpose to operate without human intervention. Likewise, there should be an open loop system, that is to be performed in a sequential manner. And PLCs are used for automation for assembly lines in industries. Uh, they are generally designed for multi-input, multi-output system. Means whenever the system which is designed to produce such a automation, such a huge logical systems, so we need to give an multiple instruction to the system to operate particular operations. So we likewise there only multiple output has to come to control their own system, because the output is very desirable thing to have to operate the programmable logic controllers. Whereas in PLCs, instructions are saved in a non-volatile memories. Okay, and advantage of PLCs. So these are all some very advantage, very good advantages of a programmable logic controllers. Whereas this kind of systems as cost cost effective, means these are all very better performers for given cost. Means the investment has to be considered as a cost. So this running cost also included in this particular concept. So cost effective means whenever the this is worth for investment. And flexibility and ability to use similar system for the other process also, means this overall PLCs can be adaptive. It can be switch over to one system program to another another set of a program by changing programs only. Means if you changing the program writing, means the set of instruction is changed, then the performing program is also changed. Likewise, this is flexible and it is has a more ability to use similar such other processes. Like programming interface is easier in comparison to other process, means the set of instructions are known as programs, so that is very easy to compare with other programs. So processors are worked based on our programming inputs only, so it has some significance to give a input and to get a desired output. So it is resistant to impact and vibration. So overall system must be a resistant to impact and vibration system. It has some mechanical aspirant, that is some resistance to impact, means the system must be an rigid and robust, and the vibration must be, it has some to avoid some such kind of vibrations, and so it won't uh, affect the performance of a PLCs. And resistance toward the electrical and mechanical noise, so it has advantage. Like the this is where which is PLCs are made from silicon chips, and likewise there are the different kind of uh, devices, so it has the very resistance towards the electrical and mechanical noises. So it has advantage over working at higher temperature, means it has ability to operate at higher temperatures. So, as coming to this basic structure of a function of a PLCs, this block diagram shows that whereas this input interface means, um, first I'll explain you once, and then I will individually explain that how this work. Means first this block is represents the input interface, means this input interface which is turned connected into input output circuit, which is external connect communication via serial port, and then this directly connected to output interface, where between that input and output it has a microprocessor. So for to operating condition of any microprocessor should have their own memory uh, to store some programs and so any necessary information. So it is having some memory devices, and mainly we need to supply some power to operate this microprocessor for processing any kind of a programs, and it will affect any programming devices has to be given input to this microprocessor. So from overall this image can tell, this input is an example, like in general purpose computer, the mouse and the keyboard, these are all the input devices, whereas coming to the output devices, a printer, monitor, these are all the output devices. And in between this microprocessor, which is an example of CPU, and this memory which is having their own in for example of in computer system, that is storing device, just like drives, power supply. We know that the power supply is an AC or DC supply for computer system. And this programming devices are which consisting of set of instruction to give the operating condition. These are all basic structures of any PLCs to have their own performing functions. And then this image showing that industrial PLCs means this programmable logic controllers which is used in a industry. You just see, this is what the programmable logic controller devices, and we are giving some input ports, means these are all the signal receiving ends, and this is signal outgoing ends. These ports are provided to get output signals. These ports are provided to give the input signal. This is all processors. This PLCs, processors. And coming to this principle of operation, where the PLCs are programmed through concept of a ladder logic. In general, there exists a graphical user interface GUI to program a PLCs that make it different from the other processors, where the ladder logic comprises of two columns. Left column shows the input devices like switch, sensor, while in output column is a right side, which shows the actuator like cylinder, motor, and then. And this principle of operation is very important as per the logic controllers are to be understand. So some short symbols which is used in a programmable logic controller. This symbol, the bracket in out, this kind of symbol which represents examine on. Normally it is opened. Means this symbol, whenever this symbol is appear, this is known as examine on, or normally it is opened. This symbol which is appeared, which shows that examine off, or normally it is closed. OTE and arrow, some open and close bracket and arrow, this is known as output energized. And OLT, that is L within bracket, that is output latch. U within the bracket is known as output unlatch. Likewise, different kinds of symbols are used, so that we need to understand some instructions. So this open bracket which shows that mm, the this instruction is called as examine or normally opened. This function is stored in a bit. If the corresponding memory bit is 1, then the respective wrong will be continuously will be executed, and then corresponding output will be energized. Wrong is a 1, the multiply the horizontal program lines with a ladder logic. For example, if you corresponding bit is 0, then the wrong will be not executed continuously. Likewise, here also, if coming to this examine of the if corresponding memory bit is 1, then the respective wrong will be continuously executed and corresponding output will be energized. And if the instruction is 0, then that is will not wrong continuously, output will be energized. If used as the input bit, its status should be corresponding to the status of real world input device tied to operate the table by identical addresses. Whereas this output energizes, the instruction set that specific bit wrong continuously is achieved. Means under normal operating condition, if the set bit corresponding to an output device, the output device will be energized when wrong goes true. For example, output bit is 0, so the slot 3 is will operated. 1, the bit 1 is slot 3, and if you use this symbol of output latch, the bit must be resetted with it will remain on even if wrong condition will go false. Then this output energize the except that in one bit it set with OLT, it is latch on. Once once on OLT bit has been set on condition. So if you come to this output latch, output unlatch, this latch bit it addressed must be same as latched 1. So it has some different kind of operation, and which you coming to observe this timer, mm, which which is timer delay, timer on T4 is to T sorry T4 is to 3, and base time is 1.0, preset is 10, and accum is less than 0. And sometimes en, so this symbol dn is known as done. This en is also known as some energies in energized devices. These timers are very important concept. This is also known as TO on. This image will shows the timer image, and it is used to turn on output on or off after timer has to been on for preset time interval. This output instruction begin timing when the wrong goes true. It waits the specific amount of time as specified in a preset, keeps track of accumulated interval which have occurred accum, and that is an output that is done bit when accum is time equal preset time as long as run condition remained true. Timer adjusts its accumulated value to each evaluation until it reaches the preset value. The accumulated value is reset when the wrong condition fails, regardless of whether timer has been out. Time base is an amount of timer which the time after accumulator increases its value to 1. So this is very important concept, that is timer. We need to understand very thoroughly as per the programmable logic controller is concerned. And you just see this an example of programmable concept of a ladder diagram. You just see this are all the important whereas this ladder diagram is considered. So you just see this is computer system, and as of this we need to understand that these are all the pneumatic cylinders, and this is conveyor. This is belt conveyor which is have the purpose of carrying, and this is pneumatic sequence module and conveyor interface module, and this is PLC, and this overall system is known as the continuation of this programming and concept ladder diagram. In this segment we will we will see how the PLCs are incorporated to control the various activity in an industry. In this illustration we have a conveyor belt run with a two motor at its ends, three different station to perform the various activity like painting of a vehicle body or fitting of any component in charges, etc., along with two switching of a run conveyor. Figure figure shows the photograph of conveyor belt system. The PLC is of bull 1764 logis 1 micro logix 1500 LSP series C van, which uh, which can be controlled by a graphical user interface L sorry yes RS logic 500 starters. And this is what the conveyor belt to run the belt with the help of switch, that is SWG motor BLU and BLU and end. These are all the programming symbols. It's the same thing which is you can see. And these are all the PLCs are controlled through a ladder logic. In input section of a ladder, the name of the input device must be mentioned on the top of the symbol, followed by the primary input port, secondary input port as mentioned just below. In similar way, the output symbols are mentioned with a new output ports as shown in the figure. You just see the concept of latching. The input output, which is a different form, that is input A and input B, which consisting of two different symbols, and the constant of the third is output, and output different two outputs. You just see the symbols is different, and the concept of the latching is very important. An illustration of an application of holding a circuit considering a motor controlled by a stop and start buttons, which and for which a single light signal light should be turned on when the power is applied to the motor, and other when it is not applied. The following figure shows that the ladder diagram when the Mitsubishi notation for the direction. A simple example of such a situation is a motor which is started by pressing a push button switch. Through uh, the switch contact do not remain closed. The motor is required to continue running until the stop the push button switch to be pressed. And what all the general requirement of a system? The starting point is determining by solution must be understand what is to be achieved. That is, the program design start with a breakdown the task into the number of simple understandable element, each of which can be easily described. The application requirement and input output device requirement. After determining the operation of a system, the system the step which is involved to determine what the input and what the output of the system requirement, and list the function required for identify a specific type of a device. The need for the special operation in additional to the discrete, that is on off logic. List the advanced function required besides the simple discrete logic, and what are all the different electrical requirement to be fulfilled. That is incoming power, the power of the control system, and output device voltage, and also output voltage, current and voltage. Output voltage and current. So, in second one, that is input device voltage, and as coming to this end, that is speed of operation. How fast does the program will occur and machine operate, that is the condition, or there the time critical operations or event that must be detected. So in what time frame must be fastest action occurred, that is input device direction to output device activations. Like does the control the system need the count pulse from an encoder or a flow meter and respond very quickly. And as coming to this communication involves the sharing the application data or status with other electronic devices such as an computer or a monitor in operator station. Communication can take place locally through an twisted pair wire or remotely via telephone or radio modems. And as coming to the operator interface, in order to convey the information about machine or a process status, or to allow an operator to input data, many application requires the operator interfaces, whereas the traditional operator interface include the push buttons, pilot lights and LED numerically display, and electronic operator interface devices display message about the machine status in descriptive text, display part count and track alarms. They can be used for data input. And as of that physical environment, how it should be, the physical environment in which the control system which be located considers that environment where the control system will be located. In harsh environment, house that control system in an appropriate IP rated enclosures. Reminder to consider the accessibility for a machine maintenance to troubleshooting the overall system or a reprogramming conditions. Thank you for watching this session from Department of Mechanical Engineering, Government Engineering College, Chamrannagar.